friends, we'll solve problem on rectilinear motion with variable acceleration. See what is given in problem. The acceleration of particle is defined by relation A equal to 25 minus 3x square millimeters per second square. The particle starts with no initial velocity at the position x equal to 0. That means when x is 0, initial velocity is what? 0. Determine number 1, the velocity when x equal to 2 mm. Number 2, the position when velocity is again 0. And number 3, the position where the velocity is maximum and the corresponding maximum velocity. Equation of acceleration in terms of x is given, therefore we will start from given equation. Therefore first A equal to 25 minus 3x square. This is in millimeter per second square, say equation number 1. Now A is given as a function of position, therefore A will substitute in terms of x. In terms of x, if we substitute, A can be written as what? V dv by dx equal to 25 minus 3x square. Now V dv term will keep on left side, as the x term is on right side, we will multiply here by dx. Therefore this equation is written as V dv equal to 25 minus 3x square dx. Now if we integrate this equation, we will get relation between velocity and position. We will continue on next sheet. Is integral of V dv, first term which is on left side is integral of V dv equal to integral of 25 minus 3x square dx. If we integrate this left side, what will get here? Integral of V dv becomes V square by 2 equal to, on the right hand side, first term is 25, therefore integration is 25x minus 3x cube by 3 plus constant of integration. To find out constant of integration, what condition is given in problem? Particle starts with no initial velocity at position x equal to 0. That means at x equal to 0, v is 0. Therefore, if we substitute x as 0 here, so this side becomes 0. V is 0, the left hand side becomes 0. That means C1 equal to 0. If we substitute C1 as 0, we will get next equation as V square by 2 equal to 25x minus 3 and 3 gets cancelled. What will get? X cube. This one is equation number 2. First equation is equation of acceleration in terms of x. Second equation, equation of velocity in terms of x. Now what is asked in problem? First part of problem, the velocity when x equal to 2 mm. Now if you want to find out what is the velocity when x equal to 2 mm, using equation number 2 it is easily possible. If we will put value of x as 2 mm, we will get easily what? Velocity. Therefore, what we will do here, we will substitute for first part x equal to 2 mm in equation number 2. In equation number 2, if we will substitute, we will get here v square by 2 equal to x is 2 mm, that means 25 into 2 minus what will get here? 2 cube. That means if we will calculate using calculator, this velocity v comes out to be 9.16 millimeters per second. But as we are getting here v square term, if we take square root, so this one positive as well as negative is possible. That means velocity of particle may be positive 9.16 as well as maybe negative 9.16 millimeter per second. This is your first answer. Second part, what is asked in problem? Position when velocity is again 0. Again, solution is possible from same equation number 2. But to find out position when velocity is 0, that means what? Find position. x when velocity is 0. Therefore, from equation number 2, now if we put velocity as 0, the left hand side becomes 0. 25x minus x cube. Solving this equation, what x will get here? Again, this is possible. What will get 5 mm? But again, what will get here? When x gets cancelled, we will get x square equal to 25. That means x, what we are getting here, this may be positive or negative. That means both, you can say plus minus is possible. X equal to plus minus 5 mm. This is second part of problem. Third part of problem, position where the velocity is maximum and the corresponding maximum velocity. To find out position where velocity is maximum, condition is what? When your velocity becomes maximum, your acceleration must be 0. That means third condition, you have to find out what in third condition. Number 3, you have to find out position, what is x, when velocity equal to maximum velocity. For this one, condition is what? For maximum. That means when your velocity become maximum, differentiation of velocity with respect to variable time t must be 0. That means acceleration must be 0. As you know, acceleration is 0. If we substitute a as 0, first equation is equation of acceleration. Therefore, if we substitute a equal to 0 in equation 1, the equation 1 becomes what? A equal to 0. On the right hand side, there are only two terms, 25 minus 3x square. Using this one, easily we will get position where acceleration is 0. That means velocity become maximum. Using calculator, if we find out, this answer comes out to a plus minus 2.887 millimeters. That means this is your next answer. But in this third part, what is asking problem, find position when velocity is maximum and corresponding maximum velocity. That means this x value, if we substitute in equation of velocity, that means in equation number 2, put x equal to 2.887, will substitute in equation 2, because equation number 2 is equation of a relation between velocity and position. X if we put in equation number 2, the second equation, this one is v square by 2. If we put this value, what velocity will get is maximum velocity. Therefore, I will write here suffix v max square divided by 2 equal to 25x, x will substitute 2.887 minus x cube, that means 2.887 and its cube, 25x minus x cube. Now solving this one, what will get here? Maximum velocity will get, and again as this is a v maximum square, therefore what is possible here is what? Plus minus. That means a positive answer is also possible, negative is also possible. There are two answers. If we find out, answer comes out to be 9.81 millimeters per second. So this is maximum velocity, and you are getting position when velocity become maximum as a 2.887, and if we substitute 2.887 in equation of velocity, we will get maximum velocity of particle. Thank you.